Well, howdy there, Internet students. This is Mr. Hermanson again here on Lesson 7.2b, Part 2, Absolute Value Inequalities. So first thing we want to do is just quickly review how you solve absolute value equations. Now remember, in a situation like this, you want to first get rid of the junk, which means anything outside the absolute value, which means this plus 3 part here. So we're going to go ahead and subtract 3 from both sides. And that gives us the absolute value of x equals 4. And then remember that there's actually 2 parts that can solve this equation, because the absolute value of -4 is equal to 4. So if we put -4 there where the x is, that would work. And also, if we have it equaling +4, it'll stay +4. So when you graph something like that, let's just put 0 here and go by ones, then 4 would be there, so we're going to put a dot there. And then -4 would be back here, we're going to put a dot there. Okay, so go ahead, you try the next one, and you can check back for this. So graphing that, we're going to have a dot at -3 and a dot at +3. All right, now on this next one, there's no junk outside the absolute value, so just go ahead and solve the 2 equations, the one on the negative side of the number line, and then and also the one on the positive side of the number line. And so you're going to have 2 solutions to that. Go ahead and finish that up, and you can check back and see if you got your answer right. So the solution looks like that. And this last one, we have a little bit of junk to get rid of outside the parentheses. Let's get rid of that +6 by subtracting 6 from both sides. That leaves us with 5 times the absolute value of 3x minus 1 equals -3. And if we divide by 5, we get the absolute value of 3x minus 1 equals -0.6. Now, remember that no matter what this is, the absolute value is going to make it positive. So this is an impossible situation. You could never get -0.6. So we're going to say there's no solution on this one. All right. So that takes us to solving absolute value inequalities. Okay, so the first thing you want to do is isolate the absolute value expression, just like we did when we did the equation. Next, you're going to choose the form of your inequality, one of either 2. If it's a greater than inequality, you're going to rewrite it like this. If it's a less than inequality, you're going to write it like this. And I'll sort of explain that as we go along here. So example 1 here. The absolute value of x is greater than 5. Just so you can see where the solutions are in here, that'll help us understand. So numbers, the places where the absolute value of x is going to be greater than 5 is any positive number that I put in here that's greater than 5, like 5.1 or 6 or whatever. So that's going to be these numbers up here and then bigger. And then also remember that the absolute value will take a negative number like -6, and it turns it into a positive number. So you're going to have some negative numbers that also will end up being greater than 5 once you do the absolute value. And that's those down there. So here's what it looks like. It looks like this is definitely going to be an OR situation, because we have this split solutions on the number line, but anything less than -5 or greater than 5. Okay, so so it's solving an absolute value inequality is a lot like doing an equation. It's just that when you have the negative part of the equation, you have to flip the sign. All right, example 2 here, this is a less than situation. again, let's go ahead and graph it so we can kind of get an idea of what's going on here. But we want numbers that are going to be less than or equal to 3. Well, that's numbers like, let's go ahead and put our 3 on here, and we'll color it in. So that's numbers going this way, like 2, 1, 0. Those are all less than 3. Now remember that the absolute value turns these negative numbers into positive numbers. So you have to think of this -1 as like +1, +2, +3. Now that all works, but when we get to -4, the absolute value makes it +4. So that's actually not going to be less than 3. So right here at -3, we have to stop. And we end up with everything in between there. So this is an AND situation where we have anything greater than -3 and less than 3. Now remember, with compound inequalities, we can actually write it like this, which means anything between -3 and 3. Whoops, I forgot the equal part of that. And when you put an equal sign, sometimes you'll hear the word inclusive included in that. All right, so example 3 here. Now we have to actually solve the equation, but it's no big deal. We're going to do it exactly the same way. We have the negative values to think about here. So what we're going to do for those is we're just going to solve for the thing inside the absolute value, x plus 2, and we're just going to flip the sign around and then make it -6. When we have greater than, that's an OR situation. And then this one is exactly the way it's written, just without the absolute value for the ones on the positive side. Okay, now we're just going to subtract 2 from both sides. And we get x is less than or equal to -8. Or subtracting 2 over here, we get x is greater than or equal to 4. Now on this side over here, we're going to get this is less than, so this is going to be an AND situation. We're going to do x minus 1, and remember, on the negative side, we're going to flip the sign and make it -4. And on the right side, we're going to leave the sign exactly the same. So we add 1 to -4 over here, and we get -3. We add 1 over here, and we get x is less than 5. So I'm going to let you go ahead and try and graph those, and you can check back to see if you graphed them right. So that's what your graph should look like there. All right. So here's your practice. You can go ahead and do a few of those and see how it works out for you.